All right, chapter 8, page 140 of Light and Life. Consider now what happens to light under these conditions. When the jet of radiating matter is at first in the form of radiation, is ejected from the nucleus, it will propagate into protospace and thus create space-time. This space-time will be bent by the large mass of the jet and thus force the photons to follow it in an envelope surrounding the jet. Figure 40b shows how a ball, or in our case a photon, will be trapped by the curvature of space-time. If we visualize the white hole as being located at the bottom of the funnel, as shown in figure 40b, and the jet of matter extending vertically upward, then the light emitted by the jet will be confined to circulate within this funnel. Light will thus follow the curvature of space-time caused by the mass of the jet and will therefore not be able to penetrate into the space between the central jet and the return flow envelope of the universe. See figure 45. A torus of protospace is thus trapped within the envelope of matter. Remember, this is still a piece of the original protospace. It is the jelly in the donut. Light is thus confined to move more or less closely along with matter. Observers located in the jet portion cannot see the light emitted by the outer envelope across the trapped protospace. They can see only along the path of matter. Light emitted by the jet or the envelope will eventually turn back on itself. Figure 45. We may ask how, at what point down the jet did life as we know it begin? The reader is aware that life on the physical level is not the only form of life there is. In fact, it is one of the latest forms of life to appear. Consciousness, as you may remember, is the underlying structure of matter and life. It has, therefore, also been the underlying principle of the black hole, white hole nucleus. As matter became more and more complex, consciousness began to manifest in the physical realities in life forms known to us. However, consciousness, intelligence, and life were always tied together and always present everywhere. There are some indications on the position of our observable universe within this big structure. By observable universe, we do not mean only the universe is limited by the range of our radio or optical telescopes. There is, however, an absolute limit to our horizon, and that is the horizon of the velocity of light. We know that all galaxies are running away from us at speeds proportional to their distance from us. In other words, the larger the distance, the faster the galaxies are running away. When the farthest galaxies approach the speed of light, they will simply disappear from our sight simply because light, having a fixed velocity of about 186,000 miles per second, will not be able to reach us since the source of light is moving away from us with a speed approaching that of the light coming in our direction. If the hypothetical galaxy will be running away from us at, say, 1,900,000 miles per second, its light can never reach us. It is therefore our absolute visual horizon. To our present knowledge, the absolute horizon lies at a distance of about 10 billion light years. The observable universe then will constitute an expanding bubble of about 20 billion light years in circumference, floating around somewhere in this much larger structure. Our position in the flow. It is possible to determine the approximate position of our galaxy within this torus-shaped universe by extrapolating from the uneven distribution of galaxies as known to us today. That is, as we look out of our galaxy into space, we find that other galaxies are not running away from us at an even clip, thereby distorting the otherwise theoretically perfect sphere of the expanding universe. The data are changing all the time, but it seems that our skies are divided into two general areas, one centering about the northern pole of our galaxy, the other area being approximately opposite to it, or about 30 degrees away from the southern pole of our galaxy. The galaxies in the northern portion seem to be running away from us faster than the ones in the southern portion of the galaxy. This also indicates that those galaxies are also more distant from us than their southern counterparts. This effect is observed most obviously in the case of the quasars, the most distant objects we can see. They form, according to Burbidge and Burbidge, two fairly clearly defined regions in the northern and southern portions of the galaxy. The northern group is spread out over a large circle about the pole, while the southern group of quasars is bunched more tightly. This would indicate that our observable universe bubble is stretched into a kidney shape, its northern portion bulging and expanding faster than the southern. This is because space-time is expanding much more rapidly in the funnel area. The little arrows drawn in the bubble show the relative rate of expansion, and the position of our galaxy is marked within the bubble, figure 46. This is, of course, not drawn to scale. Our galaxy would be just a very small speck within the bubble, and so would the bubble in proportion to the rest of the universe. Suppose now that the average level of civilization of our galaxy is that represented by our planet. We would certainly expect that all that life on galaxies older than ours, that is, those further down the line of evolution, would be much more evolved. Galaxies that are reaching the peak of the expansion of our spacetime, this occurs halfway down the outer envelope of the torus, would be on an even higher level of evolution. I am making a parallel here between the expansion or volume of space-time and the expansion of consciousness. Beyond this peak, we can therefore expect a slow decline in the general level of consciousness, which will degenerate rapidly as the galaxies draw nearer to their ultimate destiny in the black hole. We can be sure that we are sharing a universe in which all the problems that may seem to be problems to us at present have been solved over and over by civilizations ahead of us in time. We may say, therefore, that all knowledge that was ever generated is potentially available to us at some point or other in our universe. Summary. We have described the Big Bang, a concentric expansion of the universe, and the development of galaxies and stars. Our continuous Big Bang model of the universe is patterned after the jet-emitting quasar. In our model, the jet slows down, expands, and turns back upon itself, eventually forming an ovoid shape. The ovoid shape. This ovoid shape has a nucleus in its center, with is a black hole, white hole object. It is the It is the source of all matter in the universe and its final repository. Time is seen as the distance covered by matter emitted from the white hole side of the nucleus going around the shell of the torus until it enters the black hole. Our observable universe is a tiny bubble within the torus of the universe. The position of our galaxy can be located by taking into account the anisotropes in the distribution of distant galaxies. The general expansion of consciousness is linked to the expansion on the torus of the universe.